Hello, today we're going to look at identifying an unknown concentration. In today's case we're going to be using copper sulphate by the method of colorimetry. This is a colorimeter. It measures how much light is either transmitted through or absorbed by a solution. Okay. Now to do this method we first of all need to create a series of known concentrations of copper sulphate either side of where we think our unknowns lay. So in this case we're going to start with a 1 molar solution of copper sulphate, which is clearly labelled, and we're going to dilute that to 0.8 molar, 0.6 molar, 0.4 molar, 0.2 molar, and we're going to use a 0 standard, which is distilled water. From having done that, it will give us a series of readings which we can transfer onto a graph to then work out what our unknown concentrations are. So our first concentration is going to be 1 molar, okay, so which is going to obviously be straight because that's what we've got. The next concentration we're going to do is 0.8 molar. So we're going to take 8 ml of 1 molar copper sulphate, and to that we're going to add 2 ml of distilled water. Okay. Now this is being done with a measuring cylinder. Okay. If you wanted to increase the accuracy of this, okay, you could use a graduated pipette. To make the 0.6, we're going to add 6 ml of 1 molar copper sulphate, and we're going to dilute that by adding 4 of distilled water. For the 0.4, it's the opposite, it's 4 ml of 1 molar to 6 ml of distilled water. And for the final one, it's 2 ml to 8 ml of water. Now you should be doing this reasonably accurately and making sure that the meniscus of the solution sits on the line. If necessary, you can use a dropping pipette. Now as you'll see, at the moment, because of the different densities of the solution is not evenly mixed, so it's a lighter colour at the top and a darker colour at the bottom. So we're going to need to make sure that the solutions are thoroughly mixed. So in this case I'm just going to put my finger over and invert the solution to make sure that the solution is evenly mixed throughout. Now notice on the bench I'm keeping the solutions in order. You can label them with their concentration because obviously you don't want to get them mixed up, otherwise your graph will not work. Now, for the colorimeter itself to be effective, we have to look at what colour we're going to be setting it on. So the colorimeter in this case has 3 filters: red, green and blue. Now you would normally pick the filter that opposes the colour that you are doing on the colour wheel. Now the opposing colour for blue is somewhere between red and green, so it doesn't particularly matter which one we use, but as long as it's not blue. Because obviously if we're using a blue filter with a blue solution, we will not get very good or accurate readings. Now in this case we're going to set it to be on transmittance. Okay. If we look at the colorimeter, you'll find there's a power button, a calibrate button, a colour button and an AT absorption transmission button. So we're going to set that to transmission. We're going to set this, in this case it's set to R, which is red. Now what we're going to do is we're going to first of all do a standard calibration of our colorimeter. To do this, we're going to use a cuvette. Okay, now the cuvette has two sides. It has a clear side and a side with lines on. Now we're going to put distilled water to fill our cuvette about 2/3 full, making sure that it is dry on the outside, because we do not want to get any water or copper sulphate into our colorimeter. Now, if you look at the hole that we're going to slide it into in our colorimeter, there is a little light that flashes on one side, showing that the light is measured from this side through to this side, across. Okay, not up and down. So the clear sides of the cuvette need to be here and here. If they're the other way round, you will get very wonky readings. So we're going to place our cuvette with clear sides left and right into our sample, and we're going to push the calibrate button. It should then read around about 100. Okay, it will either be 100 or 99. We can place the lid on as well if we wish, just in case they were in a bright room and it may affect the reading. Okay, and this one's reading 100. So we're going to do that in between each of our samples. So we're going to take the first one, okay, and we're going to add, again, 2/3 full of our sample. In this case it's 1 molar. You will need to write down the readings I'm going to give you as we go through this. We're going to place it in. We're going to place the lid on. Still 100. And it has come out with a reading of 1.4. We're going to take that out. We're going to make up the sample for our next one, which is the 0.8 molar. Again, we're filling it 2/3 to 3/4 full. I'm going to place it in, place the cap on, and take the reading. You're going to need to write this down. It's 2.4. Now what we're aiming for is to see that there will be a difference between the readings. If there is no difference between the readings, or only a very slight difference between the readings, then we will need to change the colour filter or look at increasing the gap in our concentrations. So instead of, for example, using 0.2, 0.4, we could use 0.3, 0.6 or 0.05, 1. As long as we're able to get a reasonable spread, and we'll need at least 5 points on the graph to be able to create either a curve or a line of best fit. So this one that we're doing is the 0.6. It has a reading of 6.3. You will need to write that down. Then we're going to do the next one, which is our 0.4 molar. Okay, again, we're filling it 2/3 to 3/4 full. Okay, now it's gone to sleep. So we're going to turn it back on, and we're going to do our reference. We're going to calibrate again. Okay. And this time we've got a reading of 15.1. You'll need to write that down. And our final one, which is 0.2 molar. Has given a reading of 30.9. You will need to write that down. We now have two unknowns. We have unknown A and unknown B. So we're going to check our calibration again with our distilled water. Yep, we are still reading 100. We're going to put a sample A into the colorimeter. Again, 2/3 to 3/4 full. This is given us a reading of 9.9. So sample A is 9.9. You'll need to write that down. And finally, we're going to do sample B. We're going to check our calibration with the distilled water again. Still happily reading 100. And our final one, sample B, has given us a reading of 24.9. Now, as our readings for A and B are in between our lowest and highest readings, it means that we can plot the readings for our known concentrations on the graph and then be able to work across and read off what the molarity of our unknowns are. If the readings for our solutions were outside the scale, so for example our highest was something like 35, if we had a reading of 60, okay, that because that's outside our lowest reading, we would then have to do some more dilutions to bring that reading within the range. So that is how you work out the unknown concentration of a solution using colorimetry.